Hello students, welcome back to this video on chapter 1. So last video I had to stop quickly because my timer's running out. So we stopped at this slide here, slide number 13, the different examples of data tables. I just want to emphasize why set 1 and 2 aren't correct. Set number 1 is ambiguous because we're not sure where the values of 10 go. The first set is 0 to 10, second one is 10 to 20, the third one is 20 to 30. So where does 10 actually go? In the first category or the second category? Likewise with 20, where does it go? Second category or third category? Set number 2, the only thing wrong with set number 2 is the first category or first class, 0 to 10, is larger than 11 to 20 and 21 to 30. So that's the only problem with set number 2. In some situations you can have a data table with classes that are larger, have a larger class width than the other classes, but generally we want to make sure that the classes have that same length or size. Set number 3 and set number 4 are good. There's no ambiguity where values go. In set number 3, we know that 10 is going to go in that second set. In set number 4, 10 is also going to go in that second category. The difference between set 3 and set 4 is set 3 is used for discrete data. So we know that it's 0 to 9. We know that there's no 9.5 or 9.6 because it's discrete, it's whole numbers. And set number 4 is going to work with continuous numbers. Actually, set number 4 works with discrete and continuous. 0 to under 10 means 9.99999, but not 10. I prefer using set 4. So the examples I use in the lab and throughout the book, I will use set 4, the format for set 4, because it works for discrete and for continuous. And it makes some calculations easier later on. So what we want to do now is determining the class frequencies. We have 3 different types of frequencies. The absolute frequency is just the count of how many numbers are in each, how many of the values are in each class. So the sum of this frequency must equal n, the total number of items we have in the data set. Relative frequency is absolute frequency divided by n. So that total must equal 1, and percent frequencies is just a relative multiplied by 100%. So let's look at the example on page 13 and 14, the temperature in the last 50 days. So I've taken this this data table, put into Excel because I can write much easier in Excel. So our first category, our first value is 2. So you could start at 2, the lowest value, but because we're going up by 5 and it's easy to count by 5s, going 5, 10, 15, 20, for example, I'm going to start at 0. And I do find that is, some books are going to say, no, start at the minimum. Some books are going to say, start with whatever makes it easier later on. So that's what I like doing. We don't want that bolded. 0 to under 5, 5 to under 10, 10 to under 15, 15 to under 20. Let's make this a little bigger. 20 to under 25, 25 to under 30, 30 to under 35. Let's format that the same way and do that. So there is our frequencies, our classes. They're going up by 5. The class width is 5, even though 10 to 15, we're going to count that as a class width of 5. We can go back to our data and we can basically plug these numbers into our data table. So I'm going to move this. I think, how can I move this? So let's see. Sorry, that's what I wanted. So we have our data table, finally. We have our pieces of data. We know that there are 3 in that. No, we know there's 1. The value of 5, which occurs twice, is going to happen in the second category. So the second category is all values 5 to under 20, 5 to under 10, 1, 2, 3, 4, 5, 6, 7, 10 to under 15, 11, 15 under 20, 13, 20 to under 25, 11 as well, 25 to under 30, 4, and then 3. And hopefully that adds up to 50, as it should. There's 50 pieces of data in that example of the temperature of the last 50 days. So that's our relative, that's our absolute frequency. Now when we work with Excel in the labs doing our assignments and exercises, there's a much easier way to determine the absolute count or frequency for each category. The relative frequency is as simple as taking that absolute value, 1, divided by 50. And so we get a relative value of 0.02. I'm going to just drag that down, do an auto sum. And this is stuff we're going to learn in the labs, how to do that. Percent frequency is just taking that relative, multiplying it by 100%. So in Excel, just copy that, just link it, and then change it to a percent. And there you go. Let's get a total there. Make it nice and neat. There is our first data table. The absolute, the one where we actually have to count, relative and percent, where we just have to do some minor calculations. Okay, let's go back to our PowerPoint. So we have completed our first data table. Now the benefit of, we took the temperature of the last 50 days of data. It looks like this. There's all of our data. We made it into a nice little graph or a data table like this. One thing we can do with Excel now is create a data table, highlighting those 2 pieces of those columns. But we'll do that later. So we have a few different graphs we can talk about. I find that slide really funny. Bar graphs or column graphs. These are basically interchangeable. A column graph goes up and down. Bar graph goes sideways. In the past, it was just called a bar graph, but Excel has changed that. We can have them clustered like this one, or we can have them individual. This works well with nominal data as the x-axis. And we'll be making these graphs in Excel really easily. Pie charts. There's an example of a pie chart. Now, one thing to remember, that if you are doing reports in other courses where you're using some type of graph, is understanding that the graphs may be printed in black and white. So you want to make sure that you have the labels right near the section of the pie, instead of down here or on the side where it's really difficult to know what section each label refers to. So this is a good way to have the labels right by the section of the pie. Line graphs, Edmonton Oilers wins per season up until 2014-2015. Unfortunately, there's a downward trend, or if you're a Flames fan, that's good news. Scatter plot graphs as well. Example of that. Yeah, with this example with Major League Baseball salaries, we can plot that data and we get something that looks like this. We can put in a trend line, and we'll be doing this in one of the lab assignments as well, showing you how to do some scatter plot graphs. The exam purposes, you don't have to know how to create a bar graph or a column graph or a pie chart on the exams. We'll be just doing this for in the labs, and gives us a good understanding of the variety of graphs that we can create. The one that we'll be using in the first lab exercise and lab assignment is called a histogram. It's a special bar graph or column graph that represents the frequency distribution of continuous, interval, or ratio variables. There's supposed to be no gaps between the columns, so you will lose a mark or two if you give me this histogram for your first exercise, or your first lab assignment, I should say. There's supposed to be no gaps between. If you look at the data, this is continuous data, 0 to under 50. The next category is 50 to under 100. Basically, they should be existing side by side. So you do a histogram just like as if you're doing a column graph in Excel. And then once you have this column graph, this incomplete histogram, if you right-click on one of the columns, format data series, and reduce this gap width just down to 0, push enter, and there you have it. There's no gap width. And if you want to be really nice, you can add data labels. It gives you the frequency for each of the categories. So that's basically how you take that incomplete histogram, that bar or column graph, into a histogram for your lab assignment. And the lab assignment video will also explain how to do that. And that is the end of Chapter 1.